Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. Okay, in this video we're going to look at still the topic of 8 limits and continuity, lecture 204, and we're still in the subtopic of 8.1 limits. Okay, so we are going to discuss and look at every single term that we have, the find infinite limits, find limits at infinity, and all as you can see on the screen here. So let's try. Okay, consider the limit of function of x approaching to 0, 1 over x squared. Okay, so table below presents selected values. The function of fx equal to 1 over x squared. Okay, so these all the values of x. So okay, this is example, the number line of where x equal to 0 here, and just imagine that when the value of x approaching to 0 from left and approaching to 0 from right. Okay, so then approaching to 0 from left and right. So just imagine that if this is 1 over negative 1 squared, 1 over negative 0.1 squared, and 1 over negative 0.01 square, and the last final one here for the left side here, 1 over negative 0.001 square. And also the one coming from right side, 1 over 1 square, 1 over 0.1 square, 1 over 0.01 square, and 1 over 0.001 square. Okay. So let's see the pattern of the fx when x approaching to 0 from left and right. Okay, starting from left side here. Okay, negative 1 square equal to 1, so 1 divided by 1 equal to 1. Then next is negative 0.1 square equal to negative 0.01, and 1 over 0.01 is 10 squared, 10 to the power of 4, and 10 to the power of 6. And also when coming to from the right side, okay, so when x approaching to 0 from left, then the function of fx increase. And also when x approaching to 0 from right side, then the function of fx increase, okay, to positive infinity, and this also approaching to positive infinity, meaning that the value of y is getting bigger and bigger. So from the table we observe that limit x approaching to 0 for 1 over x squared for both left and right, okay, increase. So we come up with a conclusion that the function limit x approaching to 0 equal to positive infinity. Okay, so then from the graph of this, the domain, okay, the domain is all the values of x, we call it real numbers, except when x equal to 0, because 0 squared is 0, so 1 over 0 is undefined. Now, so when the graph approaching to 0 from right, then you can see the graph, if we refer to the y-axis of the fx, is getting bigger and bigger. And also when x approaching to 0 from left, So look at this one here now. The value of y is getting bigger and bigger to positive infinity. Okay, so then fx equal to 1 over x squared is undefined and x equal to 0. Undefined, yes, because when x equal to 0, the whole function is undefined. And also limit x approach to 0 from left equal to positive infinity, and also limit of x approach to 0 from right is also positive infinity. The limit of the function fx is undefined. Okay, so one-sided limit can be defined similarly. Okay, so the notation of one-sided limits are when fx approaching to a from left equal to positive infinity, and limit x approach to a from left of fx equal to negative infinity. Then the limit of these two, x approach to a from the right side of x equal to negative and also positive infinity here. So one-sided infinite limits. So that infinite limit, if limit of the function fx x approaching to a from the right side, okay, from the right side equal to positive infinity, and limit x approach to a from the left is negative infinity, then the limit does not exist. Okay, in this case, when x approaching to a, let's say if a equal to 0, so limit x approach to a from right side, and the graph moving up, okay, and then when x approach to a from left side, then equal to negative infinity. So just like moving down there. Yeah. So one is moving up from right side and one moving down side to the from the left. So the limit does not exist. And what about this one here now? Limit x approach to a from the right and the left, and both goes to the same direction, approaching to positive infinity from just like the previous example, then it is undefined. And also when the limit x approach to a from right side and left side move to the same direction, negative infinity to down, okay, moving downside, then limit is undefined. Okay, another criteria of limits, limit x approach to 0, 1 over x to the power of r equal to positive infinity. So the limit of 1 over x to the power of r, it is negative infinity if r is odd numbers and r in positive infinity if r is an even numbers. Okay, so what's the difference between these two? When x approach to post infinity, approach to 0 from the right side of 1 over x to the power of r. Okay, just like 1 over x approaching to 0 from right side, just let's say 0.5. Okay, 0.5 to the power of any numbers of r, whether it's odd or even numbers, we will let's say 5 equal to positive infinity. Okay, and what about this one here now? X approaching to 0 from the left side, x approaching to 0 from the left side, let's say from here, is all negative values or negative numbers. So 1 over negative 0.5 to the power of, okay, odd numbers, let's say 3. Negative 0.5 power of 3 is negative numbers. No, sorry. It's a negative numbers here. Okay. Negative 0.5 cubed equal to negative numbers divided by 1 equal to negative infinity. Okay, here. And if negative 1 over negative 0.5 to the power of 4, okay, it is equal to 1 divided by negative 0.5 to the power of 4 equal to positive value. Then it is positive infinity. So the R is odd or even number according to this one here. This is the point that we take here, 3 or 4. This is an example, simple example. Okay, now 1 over 3 minus x, limit x approaching to 3 from the right side and also 3 from the left side. Okay, this is 3, so approaching to 3 from the left side and approaching to 3 from the right side. I'll take one simple example here. This one, let's say 2.5, one example, and also here, let's say 3.5. Okay, so 1 divided by 3 minus 2.5 equal to 1 divided by 3 minus 2.5, 0.5. Okay, so using your calculator, let's come up with 1 divided by 0.5. Okay, 1.0.5 equal to 2. Okay, equal to 2 is a positive value. And let's say if I choose 1.5, so 3 minus 1.5. Okay, so then it is 1 divided by 1.5. So 1 divided by 1.5 equal to 2 over 3. Okay, so I make a correction here. Okay, 2.5 and 1.5 is when x approaching to 3 from the left side, not right side, sorry. Okay, approaching to 3 from the left side here. Okay, 1.5, 2.5, let's say 2.99. Okay, so now 3 minus 2.99 equal to 1 over 100 or 0.01. So then 1 divided by 0.01 equal to 100. So let's say 2.99. So 3 minus 2.99 equal to 0.01. Then 1 divided by 0.01 equal to 100. So limit for this one here, limit x approach to 3 from the left side, getting closer to 3 from the left side of fx, is this give you positive infinity. Okay, let's say when x approaching to x approaching to 3 from the right side. Okay, so then 1 divided by 3 minus, here is 3.5. Then of course 3 minus 3.5 equal to 1 over negative 0.5. So you can see here negative, so then 1 divided by negative 0.5 equal to negative 2. Let's try with another one. 1 divided by 3 minus, getting closer, 3.4, 3.3, 3.2, 3.1, 3.01, 3.001. Let's say 3.01. 1 divided by 3 minus 3.01, it is negative 0.01. So then, one divided by negative 0.01 equal to negative 100. Okay, so then first just now limit x approach to 3 from the left of the function fx. We proved just now it is approaching to positive infinity for this function, and also limit x approach to 3 from the right side of the function fx equal to negative infinity. So when x is 3.5, so everything here is negative 0, negative 2, and when it's getting closer to 3, 3 minus 3.01, and it gives you negative 100. So it's getting bigger here. So then, what is the conclusion then? The limit x approach to 3 of the function fx does not exist. Okay. Now, given fx equal to 1 over x minus 2 squared. Okay, so now find limit x approach to 2 from the right side, limit x approach to 2 from the left side. Okay, so then for this one here, just imagine that x approaching to 2 from the right side and approaching to 2 from the left side. So when x equal to 2 here, x approaching to 2 from the left, and x approaching to 2 from the right. So this come up with 4, 3, 3, 2.5, 2.4, 2.3, 2.2, 2.1, 2.01, 2.001. Okay, get closer and closer. And here, 0, 1, 1.5, 1.6, 1.7, 1.8, 1.9, 1.99, 1.99. Okay, so now just begin with x approaching to 0 from the right side. Okay, let's say 2.5. So then 2.5 minus 2 squared equal to, okay, 2.5 minus 2 equal to 1 divided by 2.5 minus 2 equal to 0.5 squared. Okay, so 1 divided by 0.5 squared equal to 4. Okay, so when x equal to 2.5, so x equal to, no, it's at 2.5, then whole function is equal to 4. And now, let's get closer to 2. Let's say 2.01. Okay, now, Okay, so 2.01 minus 2 square. So 2.1 minus 2 equal to 0.01 square. So then 1 divided by 0.01 in bracket square equal to 10,000. So what is our conclusion then? Just now is 2.5, 2.5 minus 2, then 1 divided by 0.05 equal to 4, and now when it's getting closer to 2, 2.01 minus 2, which is 0.01, and 0.01 square, 1 divided by everything here equal to 10,000. So this equal to positive infinity. Okay, now x approaching to 0 from left. Let's say 1 divided by 1.5 minus 2 square, 1 divided by negative 1 minus 2, negative 1.5 minus 2 is negative 0.5 square. Okay, so now 1 divided by negative 0.5 bracket square equal to 4. Positive. And 1 divided by, from 1.5 here, let's say come up with 1.99. So 1.99 minus 2 square equal to 1 divided by, so 1.99 minus 2 is negative 0.01. So 1 divided by negative 0.01 square equal to 10,000. This is negative 0.01 square. Yet it gave 10,000. So what is our conclusion then? When x is approaching to 2 from the left side, it also gives us positive infinity. Why? Negative 1.5 minus 2, then of course it gives you negative value, right? When x approaching to 2 from left, 1.5 minus 2 equal to negative 0.5. But why they give us positive here? Why give you positive value? Yes, because it has square here. It has squared here. So any negative numbers that is squared, then it turns into positive value. So limit x approach to 2 from right side is equal to positive infinity. X approaching to 2 from left also gives us a positive infinity. Then the limit x approach to 2 for the function of fx, 1 divided by x minus 2 squared is undefined. Okay. Example 3. So then determine the limit of fx, x approaching to a if exists. Okay, so let's continue. Limit, so then limit x approach to a of the function of negative 1 divided by x squared minus 1. Okay, so in this case, let's change this. Okay, x approaching to a, negative 1 divided by x squared minus 1, we can practically go we can factorize it into x minus 1 and also x plus 1. Okay. Given in the question, then it's given in the question x approaching to a, where a is negative 1, x approaching to negative 1, and also negative 1 here. So given that x approaching to, which is x equal to a, where a, it's given in the question that a equal to negative 1. So this is x approaching to a, where a is negative 1. So now, let's say this is negative 1. So x approaching to a, which is negative 1, from left, we might say that it is negative 3, negative 2, negative 1.5, and so on. And when x approaching to a from the right side, then this one come out with 1, 0, negative 0.5, and so on. Okay, now, limit x approaching to negative 1 from the right side of the function, negative 1 divided by, okay, take this one here, x minus 1 and x plus 1. Okay, so just imagine that if we substitute with okay, it's negative 1 here, divide by x approaching to negative 1 from the right side, 1, 0, negative 0.5, and so on. Okay, let's say I choose negative 0.5. X approaching to negative 1 from the right side, let's say the value of x is negative 0.5. Negative 0.5 minus 1 equal to negative 1.5. And when x is negative 0.5 plus 1, it then gives you positive 0.5. Okay, so just imagine that it is negative 1 here, negative divided by negative, and this is positive. Negative divided by negative multiplied with positive, then it gives you negative. So negative divided by negative, positive, infinity. Okay, so we just try with any value of x and just see what is sign that we have, negative or positive. And limit x approaching to negative 1 from left, which is negative 1 divided by x minus 1 and x plus 1. Okay, so just imagine that if I choose the value of x approaching to negative 1 from the left side, negative 1.5, negative 1 divided by negative 1.5 minus 1 will give you negative 2.5. Okay, negative, and negative 1.5 plus 1, that will give another negative 0.5. Okay, it's not that we substitute the value just like this, but we can just imagine that if the value is negative, if the value is positive and negative, what's gonna answer the final answer for this one here? So now it's just like negative divided by negative divided by negative. So then negative multiplied with negative will give us positive. And negative divided by positive, it is negative infinity. Okay, so we are not actually substitute the values and get the values of 1.5 or 0.5 here. We just look at the behavior, or what is the sign of what is the value of the real numbers, whether positive or negative. So we just imagine it. So then we get with a positive infinity and also negative infinity. Okay, so then what is our conclusion then? Limit x approaching to negative 1 with negative 1 over x squared minus 1 does not exist. Okay, so actually that you may just ignore the value here. We just look at the sign whether it's a positive or negative. Okay. Limits at infinity. If x approaching negative infinity, fx approaches but never quite reaches a value of n, using limit notation, we state that, okay. So if x approaches negative infinity, meaning that the value of x to the left side, from 0, negative 1, negative 2, negative 3, and so on, but never quite reach a value of m, okay, using the limit notation, we state that limit x approach to negative infinity of the function fx equal to m. Quite reaches, but never quite reaches a value of m. Okay. It's just getting closer and closer to the value of y equal to m, but it never reached the value. Then if x approach positive infinity, fx approaches but never quite reach a value of L, using limit notation, then we state that limit x approach to positive infinity of the fx equal to an L. Okay, so look at here, the graph moving towards the value of y equal to an L when x approaching to positive infinity. Okay. So use the theorem for n greater than 0. Limit x approach to positive infinity 1 over x to the power of n equal to 0. And this one here, x approach to negative infinity 1 over x of n equal to 0. And also here, and this one. Okay. X approach to negative infinity. So just imagine that approaching to negative infinity. Okay, we can, let's say, begin with negative 10, negative 100, negative 1000, and so on. So when x is, the value is negative to the power of n, I think that we just look at example just now. Let's say if I choose x equal to negative 10, okay, negative 10 with n is even number 2, 4, or 6. Let's say, let's begin with, let's take a simple example. When x equal to 2, n equal to 2, negative 10 squared equal to 100. Okay, and negative 10 when n is odd numbers, 1, 3, 5, and so on. Let's say, let's begin with 3. So negative 10 to the power of 3 equal to negative 1000. That's what we call that. For the limit on here is positive infinity when n is for odd even numbers, and its value is negative when n is an even number. Okay, evaluate the following. So now for this one here, x approaching to positive infinity when x is getting bigger and bigger and bigger. So what's going to happen in here? Okay, 1 over 0 is just like 1 over 10 equal to 0.1. 1 over 100 equal to negative 0. No. 1 over 100 is 0.01. Then 1 over 1000 equal to 0.001. So the value of 0.1, 0.01 and 0.001 is approaching to 0, right? It's not exactly 0, but approaching to 0. So we just assume that limit of 1 over x squared, 1 over x, when x approaching to positive infinity, equal to 0. It's not exactly, but very close to 0, too close to 0, right? And also, same thing goes to this one here. X approaching to negative infinity with 1 over x. So just imagine if we add up with negative here, so we come up with negative 0.1. 1 over negative 100, then negative 0.01. 1 over negative 1000, then you get negative 0.0001. So it's getting closer to 0 from the left side. So we assume that it's approaching to 0. And for this one here, limit of 8, x approaching to infinity, there's no unknown of x here. Nothing happened, nothing changed. So it is equal to an 8. Okay. And then when x approaching to positive infinity, the value of x is getting bigger and bigger, then 100,000 and so on, and to the power of 5. To the power of 5. Is getting bigger and bigger, so it's approaching to positive infinity. Limit of x approaching to negative infinity, or 2x to the power of 5. X, let's say negative 100. And times with 2 to the power of 5. Negative 100 to the power of 5 is an odd numbers. So negative numbers to the power of odd numbers, it gives you negative infinity. Okay, it's all the negative value. And what about this one here now? X. It's from x equal to 10 to the power of 6 times negative 7. It's getting smaller. So it is negative infinity. And so you can just guess that. You just imagine when x is getting smaller, or x getting bigger, substitute it to the value of our function here. What is going to happen then is the positive or negative. So in this topic, we're not talking about the value. We just look at the behavior of the function when x approaching to any value. Okay. Now, limit x approach to negative infinity of this function, and also this one here now. Okay, so for this question, x approaching to negative infinity, meaning the value of x is all negative. Negative 10, negative 100, negative 1000, all negative. Okay, so from this question, let's take a look at this x, where the x is, we call the highest degree of x, which is to the power of 5. So this determines the whole function, the whole values, or whole function here, it will give us a positive or negative. Okay, so let's say that x equal to negative 10. Negative 10 cubed is negative 1000, but negative 1000 times with negative become positive. Okay, plus with all this or minus with all this one here, but this determine because it come up with the highest degree, which is 5, and x is negative, so negative value, power of even odd numbers, is also negative. So for this one here now, it gives us negative infinity. And what about this one here now? X equal to negative, approaching to negative infinity. So x with the all even numbers. Negative 10 to the power of 8. It is positive value. But don't forget that we have negative here. So positive value x with the highest degree of 8 is its positive value multiplied with negative 4. And it ends up with negative value or negative infinity. Okay, limit and infinity for rational function. If both fx and gx are polynomial function, then divide each term by x with the highest degree power of denominator. Okay, so that's the key, the highest degree of x from the denominator. And then if limit of fx divided by square root of gx, or otherwise limit of square root of fx divided by gx, either function fx or gx with a third function, either fx or gx, and the key is with third function. Okay, so then divide each term with absolute values of x. So then for this one here, then use, if this one for both of fx and gx, both are inside the square root sign here, then use case number 1. Case number 1 here, with the highest degree of power of x from denominator. Okay, so now find out this. Okay, so as you can see all the questions here now. Okay, so then a limit of x approaching to positive infinity of 2x cubed plus x squared minus 3 divided by x cubed plus x plus 2. Okay, so for this case, the highest degree of x from denominator is 3. So x cubed is the highest power from denominator. Okay, so now we are going to divide every single term with x to the power of 3. So now 2x cubed divided by x cubed plus x squared divided by x cubed minus 3 divided by x cubed divided by x cubed divided by x cubed plus x divided by x cubed plus with 2 divided by x cubed. Okay, so x cubed divided by x cubed equal to 1, x cubed divided by x cubed equal to 1, and this gives us 1 over x, and this one gives us 1 over x squared. Okay, so we simplify this, limit x approaching to positive infinity, 1 plus with 1 over x minus 3 divided by x cubed divided by 1 plus with 1 over x squared plus 2 divided by x cubed. Okay, so just imagine that x is approaching to positive infinity, meaning the value of x is getting bigger and bigger and bigger. So 1 over big value is approaching 0. Also approaching 0. Approaching 0 and approaching 0. So this is 2, 2 and 2. So we write down as 2 plus 0 minus 0 divided by 1 plus 0 plus 0 equal to 2. Okay, so solution number 2, limit x approaching to negative infinity of the function x divided by 3x squared minus 1. Okay, so according to this one, x2 is the highest degree of x from denominator. So then, it is equal to x divided by x squared divided by 3x squared divided by x squared minus 1 over x squared. Okay. So what x divided by x squared? 1 over x squared divided by x squared divided by x squared equal to 1. Then come out with 3 minus 1 over x squared. So then x approaching to negative infinity, 1 over negative, when x is negative, negative square is positive. So 1 over big value equal to 0. And also here, 1 over big value, just imagine that if x equal to negative 100, so 1 divided by negative 100 square equal to 1 over negative 100 square is 10,000. So 1 over big value approaching 0. Okay. So then 0 and 0, so for this one here now, 0 divided by 3 minus 0 equal to 0. The next question, limit x approaching to positive infinity of the function x cubed plus 2 divided by 3x squared minus 1. So x squared, x power of 2 is the highest degree of x from denominator. So then, limit x approaching to positive infinity, then this one come out with x cubed divided by x squared plus 2 divided by x squared divided by 3x squared divided by x squared minus 1 over x squared. So now x cubed divided by x squared, x cubed divided by x squared equal to an x plus 2 divided by x squared approaching 0. This also approaching 0. X squared divided by x squared equal to 1. So then 0 divided by 3 minus 0. So if x is approaching to positive infinity, let's say x is getting bigger and bigger and bigger, 10, 100, 1,000, 10,000 and so on, plus with 0 divided by 3 equal to positive infinity. Okay. And then the question, example number 4, limit x approaching to positive infinity, cube root of 3x plus 5 divided by 6x minus 8. So then you come out with a limit x approaching to positive infinity. Okay, now x is the highest degree, power of the degree from denominator x here. So then it is, okay, I make this is what we call correction here. Let's say cube root limit x approaching to positive infinity, and the highest degree of x from denominator is an x here. So every single term that we have, well, we are going to divide by x. So then 3x divided by x plus 5 divided by x divided by 6x divided by x minus 8 divided by x. Okay. So then, now let's see, x divided by x equal to 1, 5 divided by x, when x approaching to positive infinity equal to 0, then this also gives you 0, and x divided by x equal to 1. Okay, so I'll show you that we are divided by x with every single term that we have here, and the x divided by x equal to 1, 5 over x when x approaching to positive infinity equal to 0, 0, and 1 here. So then it is now 3 times 1 equal to 3, and 6 times 1 equal to 6, which is equal to 1 over, okay, this is cube root of 1 over 2 equal to 1 over cube root of 2. So limit at infinity for rational function. So divide each term by absolute values of x. So when absolute value of x, let's refresh our, we call previous knowledge for absolute values of x, a value of x positive and negative when x is approaching to greater than 0, and this one when x is less than 0. Okay. For polynomial functions, the x approaches the positive infinity, then x is as positive for square root of x squared, and this one here. Okay, let's see. We're going to check what we call the solution one by one. Okay, now the first one, where limit x approach to positive infinity of the function x plus 1 divided by square root of x squared plus 1. So divide each term by the modulus of x. Divide each term. Okay, because we got square root of x squared here, okay, square root of x squared, so we are going to divide each term by modulus of x, or absolute values of x. So for this one here, now come out with limit x approaching to positive infinity, where x divided by x plus 1 over x divided by square root of x squared plus 1 divided by square root of x. So in this case, we come up with limit x approaching to positive infinity, square root of x divided by x equal to 1, and this is 1 over x. X approaching to 0, 1 over big value, come up with 0 here. And then, let's say 1 plus 0 divided by, and for this one here, square root of x squared divided by square root of x squared equal to square root of 1 plus 1 over x squared. Okay, I think that again should be come up with 1 over x. Okay, so now x approaching to positive infinity is getting bigger and bigger, 10, 100, 1,000 and so on. So 1 over big numbers, which is equal to 0, and also here approaching to 0. So then 1 plus 0 divided by square root of 1 plus 0 equal to 1. Okay. The second solution here, limit x approaching to negative infinity, where x plus 1 divided by square root of x squared plus 1. Okay, divide each term with absolute values of x, because square root of x squared equal to modulus of x for this one here now. So then limit x approaching to negative infinity is x divided by x plus 1 divided by x divided by square root of x squared plus 1 divided by square root of x squared. So we come out with the limit of x approaching to negative infinity, x divided by x equal to 1 plus with 1 over x. Okay, and because x approaching to negative infinity, then come out with negative square root of x squared divided by x squared equal to 1 plus 1 over x squared. So now 1 plus with x approaching to is getting smaller and smaller, negative 10, negative 100 and negative 1,000, all that is approaching 0 here, approaching 0, and also approaching 0 here. So 1 plus 0 divided by negative square root of 1 plus 0 equal to negative 1. Okay. Remarks. If square root of x power 4 equal to x squared, for polynomial function is divided by x squared, and for square root function is divided by square root of x to the power of 4. Okay, let's see. Limit x approaching to infinity of x plus 1 divided by square root of x to the power of 4 plus 1. Then this come out with a limit x approaching to infinity of x divided by x squared plus 1 over x squared divided by square root of x, x to the power of 4 divided by x to the power of 4 plus with 1 over x to the power of 4. Okay, so now substitute x with infinity here, and it gives us x divided by x squared 1 over x plus 1 over x squared divided by square root of x power 4 divided by x power 4 equal to 1. Okay, 1 plus 1 over x to the power of 4. So x is approaching to infinity with the positive and negative. Let's say positive here. This approaching 0, approaching 0, and approaching 0. So then it is 0 plus 0 divided by square root of 1 plus 0, then it is equal to 0. 0 divided by 1 equal to 0. Okay, so let's take a look at this one here now. The first one, x approaching to negative infinity. Okay, just imagine that imagine x equal to negative 10. Negative 10 squared equal to 100. 100 and 3 times negative 10 equal to negative 30. So 100 minus 30 equal to 70. Still a positive value inside here. And then minus with negative 10. Negative with negative 10. Just imagine that something like this. A negative 100 square plus 3 times negative 10 and minus negative 10. Okay, so negative 10 square equal to 100. And then 3 times negative 10 minus 30. So negative 100 minus 30 equal to negative 70. So equal to square root of 70 is still positive infinity. Negative times negative, positive, and 10 is still positive infinity. So positive infinity plus positive of infinity, positive infinity. Okay, then the second one here now. The second one here. Now x squared plus 3x minus x. X squared plus 3x minus x. Okay, so for this one here now, we are going to multiply with the conjugate of this. Okay, so for this one here now, we are going to multiply with the conjugate of this, which is square root of x squared plus 3x plus with an x divided by square root of x squared plus 3x plus x. Limit x approaching to positive infinity. For this one here, square root of x squared plus 3x multiplied with this one here, it gives you x squared plus with 3x, because this we call square root of x squared plus 3x plus with an x is a conjugate of the first term here, the question itself. So you come out with x squared plus 3x minus x squared divided by square root of x squared plus 3x, then plus with an x. So x squared minus x squared, then come out with now 3x divided by square root of x squared plus 3x. So look at this one here now. The highest degree of x from denominator is considered as an x, even though it's x squared here, but we have a square root. Then come out with we divide it by the absolute values of x. So now that is not 3x divided by x. We consider this the highest degree of x from denominator equal to an x, because x squared and square root equal to more absolute values of x. So then now become 3x divided by x divided by square root of x squared divided by x squared plus 3x divided by x squared. Okay, I forgot something. We got x here, so means that for this one plus with an x divided by x. Okay, now a limit of x approaching to positive infinity. So x divided by x equal to 1. This is also 1. X divided by x squared, 3 divided by square root of x squared divided by x squared, 1, plus with 3x divided by x squared, then we got 3 divided by x, plus with x divided by x equal to 1. Okay, so x approaching to positive infinity when x is getting bigger and bigger, so this approaching to 0. So finally come up with 3 divided by square root of 1 equal to 1, plus with another 1, then it is equal to 3 divided by 2. So then the conclusion here, okay, so I think that you can recall, you read the notes and try to understand the solution one by one, and can continue out with your tutorial. Hopefully it helps you to understand what it's all about this recording process of this the content in this video. So till we meet again, as always, Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.